Yeah. Dear participants, welcome to Aura 2023. You can send your question about the Congress via email or WhatsApp message. You can download your participation certificate from system after the presentation. Is there any question? Okay. We can start first presentation. Mehmet Batuhan Özdaş. Okay, Ahmet Seyfullah. Dear Furkan, can you hear me?
Yeah, I can hear you. Is there any question?
Okay, you can start.
I like to start, but my friends, maybe they want to start in their order, but I am able to start now. I can directly start if you like.
What is the name?
The research name.
Yeah.
Generating personalized abstract art paintings by using people's life energy distribution. It's at the 7th row.
Okay.
Should I share my screen to you?
1 second.
Okay, I'm waiting.
Okay, you can share screen.
Okay, thank you. Can you see my screen?
Yeah.
So I will start with the first slide of the presentation. I can start now, if you like.
You can start, no problem.
Can you see my presentation screen?
Yeah.
Okay, I'm starting now. Hello, I am Furkan. Today, I am going to make a brief presentation about our study. It's generating personalized abstract art paintings by using people's life energy distribution. Also, the assistant professor Ferishtah is the advisor of the study. The outline. The topics we are going to examine now are listed in here. So let's start with the introduction. Data visualization is visual expression of data with mathematical calculations. It's a highly effective way to transfer and understand the features of the data, like structures and the meanings. It allows people from different fields work and understand the data in the same ways, choosing right methods for the data and considering the audience is important to achieve this. Data visualization is always used in history, but it changed to something else when it meets today's technology. Like today, the data is different now, such as IoT and social data, and we have different systems now. We are using real-life data in our study, people, and we also inspired by the real life. We inspired real-life botanical trees. Through history, science, and arts merged in various studies. Our artistic data visualization system uses the real-life data, activities of people, and generates color field style and abstract art genre paintings. In the study, we have created an art style with mathematical basis to produce it's asks something. Okay. In this study, we have created an art style, a sub-art style with mathematical basis to produce an artistic and mathematical visuals. Okay. In the study, we developed an artistic visualization system on tree data structure. As you know, tree is widely used structure. How widely? There are over 300 methods to just visualize the tree data. You can see a couple of them in these figures, the 4 figures. Tree data has hierarchical structure, and we can list many examples in real life, like family trees, genetic trees, or computer networks. Before talking about system details, we like to give some brief terms of definition. I'm just gonna read and interpret these definitions for you. Distribution of people life energy. You can see the figure A. It's the main data of the study. How people spend their physical energy, life energy from the different activities in their lives is completely subjective and vary from person to person, and it provides us uniqueness. The uniqueness is important if you try to produce an art. The content image, also the figure B, like I mentioned, we inspired by the real-life botanical trees, and this tree visualization, the content type, is our base visualization. See, style image or filter. At this study, we have Neural style transferring phase, and we have paintings as style images. At the D figure, you can see an example, a sample output image. When we use neural style transferring with B and use C as filters, we get D, generating image. There are normally 2 approaches for image generation. One is using ML, the machine learning. In those type generation, you have to teach something to your system. You need some image library, but we use the second version, the creative computation and creative algorithms, because we don't have any starting points and we create something with creative algorithms. The materials. There are plenty of materials we use to make this project happen, but we are going to mention about the data material of the study for this presentation. So the person data is the first data. It consists from personal data of the user. The personal data, you know what it is. It's the personal data. 5 colors and 3 painting selection of the user, and also the main tree data, the life energy distribution data we already mentioned at the definition of terms. You can see this data in JSON format, which we use in our system at the right side of the screen. Art data. We have 200 selectable paintings by the user from 20 different artists, so 10 paintings for each artist or painters. We are using both the colors and the textures and styles of these paintings. We also use the genres and the styles information of these paintings at the final phase of the study to provide an artistic information to our users. The color data. Colors are important for this study. There are 7 total palettes and 35 total colors used to make artistic data visualizations. First palette, the top one, is the 5 favorite colors of the users, also named as or referred as users palette. Following 3 palettes came from the selected paintings of the user, and the last 3 is calculated over the user palette. Methods. We divided our system to 4 main parts, may referred as the 4 main methods. You can see the flow between these methods at this figure at the center. First one is data collection. We created different types of surveys to collect data from users. We create various ways to be compatible with the people. The most significant survey by us to general user face survey application. You can see the interfaces at the figure at the below. The other surveys are actually online surveys. They based user manuals. That way user can follow the clear stages and provide the information that we need. The second one is content image generation. We are using creative algorithms under computational creativity. The system pre-process the data and construct an array tree, which means every node can has various number of childs. Although the system is able to make various content images like this, we call the content image as the special merge, the content image. That one we use in the neural style transferring phase. We call the content image as the special merge of the background and the foreground content images. Like you see, our interface, there are some sections, the BG and FIGI, the background and foreground. We use special merge of them to create the content image. In the content image generation, the colors are frequently used in prioritized circular order. You can see the several of content images we generated. Results or output image generation. After generating the content image, we use the selected paints of the user. We use the style and texture of these paintings, the selected paintings. We are using a well-known, well-developed NSPT IPMB implementation. We don't have our special NSD system yet, because in this study, we are focusing creative algorithms, computational creativity, and art. But still, there are 20 options for this implementation, and we tested each of the options to make the system special as possible for our study. You can see a content image and a result image with the selected paintings at figure below. The user data evaluation phase is the last phase of the study. At this phase, we use our system to create evaluation file of the user. This file has plenty of informative data from the all phases of the study of the system. We collect these files to keep our results in same one way. We also send this result file to users to thank them and inform them about their results and their RPs. Experimental studies. You can see figure at the left side of the screen. It gives a brief visual overview of the general processes for two different users. A is user's color selection. B is the tree content images. It's the base visualization method. Every other content images generated over this, like I said. At the C, you can see the content images before the NST, neural style transferring phase. D shows the painting selections of the user, and E shows the output images of the two users. It's a personal opinion, but I think they look wonderful. The figure at the left shows how different selections of the user affect over the same energy distribution data. 1 shows the painting selections, 2 shows the output images, and 3 shows the user's color selections. E and B has same color selections, but they have different painting selections. As you see, colors are very likely, but textures and styles are different. B and C has the exact same painting selections, but the user color selections are different. So at the output image side, the texture are same, but the colors are different. There are some samples we prepared for you, we generate for you. Conclusion and future work. Using right method, like I said, considering the data and target is vital for data visualization. In our study, we go beyond just the data visualization. We created artistic results, and our results are consistent with each other. Hence, we can say we created a new sub-art style under the color field and abstract art. We created art, but we also keep the mathematical grounds. This is not just creating artistic visuals. We are generating reflections of people with abstract art inspired visualizations. As a future work, we plan to license the paintings and provide an online service for companies and individuals. We want to add activities in categories, hence divide them in the categories to use all the data we have in mathematical calculations. Also, today's companies want to learn more about their candidates. So the HR department of the companies can generate and compare the result of the arrival, the new employee with the team to see how compatible each others. The users who provide the data to us also love their results. So we believe we may sell these special painting-like images to people. and the references. Here are the references we used during this presentation. Thank you for your listening. Thank you for your time. If you have any questions, you can ask now.
Thank you for your presentation.
I think I'm thankful for your chairman.
Is there any question? Okay. Next presentation. Dear Özdaş.
Yes, I'm here.
Okay, you can start.
Thank you. Can you see my screen?
Yeah.
Hello, everyone. My name is Batuhan, and I'm a master's student at Gazi University. And I'm going to present to you our paper today, and it's called the Super Resolution Image Acquisition for Object Detection in the Military Industry. First, I will mention the problem of this study. With artificial intelligence, studies in the field of military industry have increased lately. One of the areas of this artificial intelligence study is called object detection. But the problem with the object detection is detecting small objects, not large objects, because large objects are easier to detect. So we will concentrate on detecting small objects. So that's why our paper aims to facilitate object detection algorithms by enlarging images. When we are enlarging images, we are enlarging objects. So we will facilitate object detection algorithms. But when we are enlarging images, we may have some quality problems. We are not just using enlarging images, we are improving image quality by using fast super resolution convolutional neural network, and it is called FSR-CNN. And we are improving this FSR-CNN for better image quality with less computational data and less training time. And here's the datasets we use for our paper. There is no prepared military dataset in the literature, so we had to collect ours from the internet manually, and we collected 900 images. Our dataset consists of 9 classes, and the collected 900 images are used for testing the FSR-CNN models. Of course, we need some training images for training the model, and we acquired this training dataset from the testing dataset by using data augmentation techniques that I will talk about just now. Here's the dataset samples we used in the study. We had some 8 military objects and 1 non-military objects. Here's the dataset augmentation techniques we used. Data augmentation is simply the process of diversifying datasets. We are creating copies from just one image by using these techniques. We used 8 different techniques for data augmentation. 5 of them, the first 5 of them is called geometric transformations, and the last 3 of them is called pixel transformations. Geometric transformation is simple and well-known technique, so we will mention about pixel transformations. The first pixel transformation we use for data augmentation is Gaussian filtering. It's also called Gaussian blur because it blurs the image. The reason it blurs the image, it is suppressing the high frequency values. When we look at the figure below, we can see the high frequency values are being suppressed and the low frequency values are being passed. Here's the formula for some Gaussian kernel, and we are creating Gaussian kernel by doing this formula. After that, we are convoluting this Gaussian kernel with the original image, and we are getting a Gaussian filtered image. The second pixel transformation we use is brightness changing. For 8-bit images, the values are between 0 and 255. 0 represents black values, and 255 represents white. So if we want to increase brightness, we have to bring values closer to 255. If we want to decrease the brightness, we have to just opposite of it. With the given formula below, it just does what I just explained to you. Contrast changing, we are increasing the contrast of the images. For that, we are using a contrast limited adaptive histogram equalization. But for knowing this, we had to first know the histogram equalization. The first step of histogram equalization is the calculation of unnormalized histogram. We are just calculating every pixel's unnormalized histogram by using the below formula. After this formula, we are using the given formula, and we are getting we are increasing the contrast by using histogram equalization method. But the problem with the histogram equalization method, contrast increases too much, and the noises become easier to see. The reason for that, in the image, we have some different regions, and these different regions have some different contrast. So because of this different contrast, this contrast can affect each other in a bad way. So to eliminate this problem, the method we proposed is dividing images into parts. When we are dividing images into parts, every parts will have a similar distribution. What this distribution is, histogram. It's just will have similar histogram values. So that's why we will eliminate these regions can affect each other. But when we dividing image into parts, and every parts we will apply histogram equalization method. When we do that, the noises in the image are so apparent to see. So we had to eliminate this problem too, and the histogram equalization method is doing this by using clip limit value. Clip limit value is simply just clipping the histogram values, and noises in the image do not become apparent because of this clip limit value. For CNN studies, normally we have some input image and we have some reference image. Reference image is used for comparing the output image, so we can train the model. Same thing goes for FSR CNN as well. We have two images needed. The input images are low resolution images, and the reference images will be high resolution images. The images we collected were high resolution images, so we needed to have some low resolution images, and we acquired this low resolution images from high resolution images by using bicubic interpolation method. Before talking about FSR CNN, we need to first know super resolution convolutional neural network. It's SRCNN, it's called SRCNN. It simply aims to recover high resolution image from low resolution image. When we look at the figure below, there's a low resolution image for input images. We are enlarging it by using bicubic interpolation, and we are getting some high size images, but it's still poor quality. It still has poor quality. To improve this quality, we have used SRCNN model. An SRCNN model consists of 3 convolutional layers. First convolutional layer is doing extracting features from this low resolution input image. We are extracting the features, and we are getting a low resolution feature map. The cubic shape here can be seen. After that, the most important part is the mapping part. Here we are mapping this low resolution feature map into the high resolution feature map. And the last one, we are getting a high resolution image from this high resolution feature map. But the problem with the SRCNN is when we are enlarging images in the beginning, this means we will have more number the process in the convolutional layers. And this means we will have some more computational data and more training time. So authors proposed SRCNN that can propose FSRCNN. So I'm going to talk about the differences between them. As we can see here in the figure below, there is no processing in the beginning. There is no enlarging images, or there is no bicubic interpolation method we use. We are just using our low resolution images as input image. We are still extracting the features by using some convolutional layer, and we are getting low resolution feature map. But we need to reduce the depth of this feature map by using shrinking method to get lower computational data and lower training time. After this, getting lower low resolution feature map, the mapping part is the same with SRCNN. We are just mapping low resolution feature map into the high resolution feature map. But we were shrinking the low resolution feature map here. So we had to expand this high resolution feature map again. So expanding part here is just the opposite of shrinking part. And we are getting in the beginning a high resolution feature map. And we have some deconvolutional layer here. The convolutional layer is just the opposite of convolutional layer, and it is used to enlarge images. So the difference between them is using doing enlarge process, not in the beginning, but in the end, and by using the convolutional layer. For our proposed model, we need to talk about VGG16 model as well. VGG16 model is a well-known model for our artificial intelligence studies. It has 13 convolutional layers to extract features, and it is known as a good feature extractor. The reason we use VGG16 model is because it's already pre-trained and it already has weights and no need training. So by using VGG16 layers, we are trying to aim less computational data and less training time. And the proposed model here can be seen in the figure below. We are removing the feature extraction part, and we are just adding the first two layers of the VGG16 layers. As I've told you before, it already has weights. It is already pre-trained, so there is no need for train these weights. So we will have less training time and less computational data. And because VGG16 is a good feature extractor, even if we train this feature extraction part here, we will have some bad results than VGG16 layers, because VGG16 layers have some better feature extractor. The reason we use only the first two layers, because of these pooling layers here, because pooling layers is just reducing the sizes of images. But this paper is all about the super resolution. So if we reduce the dimensions of the images, we may have some bad results. So we use just the first two layers. Of course, we can use this other convolutional layer without using pooling layers as well. We tried it, but the more complex we make the model, the worse results we got. So we tried to keep the model as simple as possible. Here's the parameters we use for our experiments. Of course, we tried different parameters as well, but this was the parameters that gave us the best results, so we used them. There is an unknown parameter here. It's called set of images. When we train our FSR-CNN model, we have some limited RAM problem because we have 9,000 training images. So we just divided our images into clusters, and these clusters have 450 images. We just send these 450 images to model. We train the model by 50 iterations. We save the weights, and after the training is done, we send another cluster to the model, and we keep going this way. For the test results, we used BRICS score. BRICS score is simply image quality metric, and it's without a reference image. It is not using a reference image. Smaller BRICS score means better image quality. Here's the results we got when we look at the first two rows of the table. When we are using VGG16 layers instead of using some convolutional layer, we can have some, as we can see, we are getting a 56.5 BRICS score. But when we use VGG16 layers, our BRICS score is better. So when we look at the third row of the table, as we can see, more complex model, when we made the model more complex, we got the worst results. And here's the proposed model we got, and it's the fourth row of the table. As I told you before, we tried to keep the model as simple as possible. And when we look at the last two rows of the table, when we are using VGG16 layers, we are achieving better BRICS score. So here's the conclusion and future work. Small object detection for the military industry is more important study than a normal object detection or large object detection. So our proposed model aims to facilitate object detection algorithms by enlarging images and by improving the quality of the images. So proposed model is just a combination of VGG16 and FSRCN model. With the improvement we made, better results are achieved with less training time. Object detection will be done with test images obtained from the proposed model. Thank you for your attention. I can have questions if there is any.
Thank you for presentation.
Thank you.
You're welcome. Is there any question? Thanks again. Next presentation, dear Doruk.
Yeah, me are here, and I present this presentation.
Okay, you can share on screen.
Okay. Is there any problem for my screen? Yeah, sorry.
No problem. You can share your screen.
Yeah. Okay. Probably that's my computer. Yeah. Sorry. Yeah, now there's no problem, I guess.
Yeah, you can start.
Yes. Hello again. I'm Osman. I'm master student in Yıldız Technical University in Intelligent Transportation System. Before the presentation, I want to thank you for all these participants. We are so happy to being there. In this presentation include these parts. After the presentation, we will curious about the article and your opinion and feedback. Actually, with the popularization of satellites and aerial vehicles, detection of small objects has become important. With this came two problems. First, success, accuracy. Since the size of the objects in the image much smaller than the size of objects taken from a normal camera, and the accuracy is much lower, especially for classes such as pedestrian objects. To increase accuracy, neural network models have become more complex, and this has led to an increase in processing time. At these two stage difference model used, single layers and two-layer models. Although two-layer models are more successful, the processing this time is longer. Single-layer models are faster, but have a lower accuracy rate. In this project, we developed a model for multi-scale object detection using for YOLO 5 models, which is one of the faster single-layer model. We used the YOLO 5 model in our study and added SFA and EFF and dynamic head modules. After these page, I will explain these modules. Our Solve YOLO 5 models consist of three parts. These parts are backbone, neck, and head parts. We use DarkNet 53 architecture in the backbone part. DarkNet 53 is a popular convolutional neural network architecture using in computer vision. Particularly, especially in object detection. It consists of 53 convolution layers, and it knows for its deep structure, allowing it to capture complex patterns and semantic information. The networks employs convolutional layers, activational functions, pooling layers, and skip connection to extract features at different scales. Darknet 53 has been successful in achieving high accuracy and speed in real-time application. We developed the architecture for the neck part using scale-aware function. It calls CEF, aims to dynamically determine the optimal scales for different objects rather than relying on a fixed set of scales. The scale-aware function techniques typically involves two main steps. Multi-scale feature extraction, the input image is processed through a deep neural network, such as a convolutional neural network like CNN, to extract a set of multi-scale features. These features capture the hierarchical representation of the image, including low-level details and high-level semantic information. Scale fusion, the extracted multi-scale features are then fused or combined in a scale-aware manner. This fusion process involves adaptively highlighting the features based on their relevance and contribution to detecting objects at different scales. The ways are usually learned through a training process that optimize the detection performance. We use EFF modules to combine these feature sets to effectively integrate abstract and spiritual information. The EFF module multiples unsampled low resolution features set with a weight vector prior to adding it with a high resolution feature set. The weight vector reflects to the importance of low resolution features, and it's calculated over the concatenation of low and high resolution features, which are initially processed with a skews and exaction network, then sent the global aware pooling layer, following by the sigmoid function. In the head part, we use the dynamic head module, as you can see. With dynamic head, the architecture of the head is adapted based on the input image. And this adaptation can include modifying the number and types of layers, adjusting the spatial resolution, or changing the output formats. The goal is to customize the head architecture to be more suitable for the specific image, improving the detection performance. Dynamic head often involves a two-step process. Firstly, image analysis. The input image is analyzed to extract relevant information, such as the complexity of this process of certain objects or patterns, or the distribution of objects. This analysis helps determine the head architecture for the given image. Head adaptation based on the analysis, the head architecture is dynamically adjustment to optimize the prediction for the specific image. And this can involve adding or removing layers, adjusting for the receptive field size, or changing the output formats. Our data set was provided by Turkish technology team. And this dataset consists of images taken from the drone cameras. These images were recorded from 25 and 1,000 meters altitude and 60 to 90-degree angles. And the resolution of the image is 1920 to 1080. And the dataset also include images collected at the different times of the day and in the different season. And they are 4 different classes in the dataset. These classes are pedestrian vehicle, landing area, and takeoff area. Finally, and the dataset contains 380,000 labeled objects consisting of 4 labels at 4 different class. In the figure, you can see the distribution of each objects in dataset. And top table shows the contribution of each module added to the YOLO 5 module. With the modules, we added the map value increased from 74 to 80. The middle table compares our model with the most widely used single layer objects detection models. It seems that our SOV YOLO 5 object is more than successful than other models. The last table shows the success values of the YOLO 5, YOLO 5 based TPH YOLO 5, and our own modules on each class. According to these values, it seems that our module has higher accuracy than the other 2 models, especially in the pedestrian class. You can see some images taken from our data sets. Thank you very much for listening. I would love to hear your question and feedbacks.
Thank you for presentation. Is there any question? Okay, next presentation.
Yeah, thank you.
You are welcome. Dear yazar, Ozan yazar.
I'm here.
You can share your screen.
Turgut Hocam, Türkçe sunmamda bir sıkıntı var mı? Türkçe sunabilir miyim?
Sunabilirsiniz.
Tamam, teşekkürler. Öncelikle herkese merhaba, ben Ozan Yazar. Bugün sizlere hibrit elektrikli araçların enerji yönetim stratejisine bağlı reinforcement learning tabanlı bir enerji yönetim stratejisi üzerine yaptığımız çalışmayı aktaracağım. Özet olarak baktığımızda son yıllarda hibrit elektrikli araçlar için enerji yönetim stratejisinin tasarımında derin pekiştirmeli yani reinforcement learning algoritması kullanılmakta. Pekiştirmeli öğrenmede algoritmanın bir enerji yönetim stratejisi olarak gerçek zamanlı uygulanabildiğini araştırılması, eğitim süresi, yakıt tasarrufu, şarj durumu yani state of the charge sürdürülebilirliği açısından kritik öneme sahiptir. Bu amaçla hibrit elektrikli araçlarda yakıt tasarrufu için Deep Deterministic Velocity Gradient algoritmasının geliştirilmiş bir versiyonu olan Twin Delight Deep Deterministic Velocity Gradient algoritması önerdik. Mevcut Q öğrenme tabanlı takviyeli öğrenme, Deep Q Network tabanlı ve Deep Deterministic Velocity Gradient tabanlı derin takviyeli algoritmalarla karşılaştırdığımızda önerilen TD3 algoritması istikrarlı eğitim verimliliği, umut verici yakıt ekonomisi ve çeşitli sürüş döngüleri altında daha düşük bir state of the charge varyasyon aralığına sağlamaktadır. Temel amacımız bu bölümde sunulan güç paylaşımlı hibrit elektrikli araçların modelinde TD3 algoritmasının performansını geliştirmektir. Bu çalışmada hibrit elektrikli araç tipi olarak güç paylaşımlı yani Power Split hibrit elektrikli araç seçilmiştir. Power Split hibrit elektrikli araç en başarılı güç aktarma organlarından biri olan hem seri hem de paralel hibrit elektrikli araçların birleşimidir. Power Split hibrit elektrikli araçların genel yapısı şekilde gözükmekte. Bu elektrikli araçlarda temel olarak bir elektrik motoru, bir tane içten yanmalı motor, jeneratör, piller ve planet dişli sisteminden oluşmakta. Power Split hibrit elektrikli araçlarda tahrik gücü hem içten yanmalı motor hem de elektrik motoru tarafından sağlanır. Bu nedenle güç paylaşımlı yani Power Split hibrit elektrikli araçlarda birden fazla güç kaynağına sahiptir ve bu da ekstra derecede kontrol özgürlüğü sağlar. Bu nedenle birden fazla güç kaynağı sahip sistemlerde uygun bir enerji yönetim stratejisi kullanılmak zorundadır. İçten yanmalı motor ve elektrik motorunun sağladığı gücü yöneten bir enerji yönetim sistemi ile hibrit elektrikli araçlarda emisyon, yakıt tüketimi azaltılabilir. Enerji yönetim stratejisinde temel amaç hibrit elektrikli aracın yakıt tüketimini, emisyon değerlerini ve araç performansını optimize etmek için güç kaynakları arasında yani içten yanmalı motor, elektrik motoru arasında güç dağılımını kontrol etmek ve ayarlamaktır. Son yıllarda makine öğrenimi ve yapay zeka alanlarındaki atılımlara dayalı olarak hibrit elektrikli araçlarda enerji yönetim stratejisi geliştirmek için çeşitli makine öğrenimi teknolojileri uygulanabilir. Makine öğrenimi bilgisayarların açık programlama yerine veliler tarafından yönlendirilen ve görevleri gerçekleştirmesine izin veren bir araştırma alanıdır. Makine öğrenimi eğitim verilerinin nasıl yapılandığına bağlı olarak supervised, unsupervised ve reinforcement learning öğrenme olarak sınıflandırılabilir. Bu çalışmada hibrit elektrikli araçlar için pekiştirme öğrenme teknikleri kullanılarak farklı enerji yönetim stratejileri kullanılmış ve karşılaştırma yapılmıştır. Kullanılan reinforcement learning tabanlı enerji yönetim stratejilerine baktığımızda ilki Q-learning tabanlı, ikincisi Deep Q Network tabanlı, üçüncüsü Deep Deterministic Policy Gradient tabanlı ve sonuncusu Twin Delight Deep Deterministic Policy Gradient tabanlı enerji yönetim stratejisidir. Bu çalışmada hibrit elektrikli aracın enerji yönetim stratejisi için belirlenen demin saydığım 4 tane pekiştirmeli öğrenme algoritmaları kullanılarak simülasyon çalışmaları yapılmıştır. Simülasyonları farklı yol koşullarında karşılaştırmak amacıyla 3 farklı sürüş çevrimi kullanılmıştır. Bu sürüş çevrelerine baktığımızda ilki Yeni Avrupa Sürüş Döngüsü NEDC, Kentsel Dynamometre Sürüş Programı UDDS ve dünya çapında uyumlaştırılmış hafif taşıtlar test prosedürü VLTP olmak üzere 3 tane sürüş çevrimi kullanılmıştır. Sürüş çevrimlerinin hız zaman grafikleri de şekilde verilmiştir. Simülasyon sonuçlarına baktığımızda takviyeli öğrenmede eğitimdeki ödüllerin yakınsama kararlılığı, aracın doğru davranışlarını öğrenme ve hedefe daha hızlı ulaşması için oldukça önemlidir. Önerilen ödüllerin yeterli ve orantılı olması algoritmaların öğrenme sürecinin verimli ve başarılı olmasına yardımcı olur. Şekilli incelediğimizde kullanılan 4 reinforcement learning tabanlı enerji yönetim stratejisi için yakınsama hızı ve ortalama ödüllerinde farklılıklar gösterilmiştir. Q-learning ortamında baktığımızda ortalama ödülün yaklaşık 170. turda, Deep Q Network'te 140. turda, Deep Deterministic Policy Gradient'ta 11. turda ve TD3 için ise 6. turda kararlı hale geldiği görünmekte. Takviyeli öğrenme tabanlı enerji yönetim stratejisine baktığımızda ortalama ödüllerin yakınsama oranları karşılaştırıldığında TD3 tabanlı enerji yönetim statüsünün en hızlı yakınsadığı ve daha kararlı olduğu tespit edilmiştir. Kullanılan 4 reinforcement learning tabanlı hibrit elektrikli aracın yakıt tüketimi ve son state of the charge değerlerine baktığımızda TD3 tabanlı enerji yönetim stratejisi için NEDC sürüş çevriminde yakıt tüketimi 100 kilometrede 3.44, VLTP sürüş çevriminde yakıt tüketimine baktığımızda 100 kilometrede 3.5, UDDS'ye baktığımızda ise 3.19 litre olduğu tespit edilmiş. Karşılaştırma yapıldığında TD3 tabanlı algoritmanın diğer pekiştirmeli öğrenme algoritmalarına göre daha iyi bir yakıt ekonomisi avantajına sahip olduğu görülmekte. Sunumum bu kadardı. Dinlediğiniz için teşekkür ederim. Herhangi bir sorunuz var mı?
Thank you for presentation. Next presentation, dear Nemati.
Hello, do you have my voice?
Yeah, you can share your screen.
Sure. Let me share my screen.
Yeah.
Do you have my screen?
Yeah, no problem. You can start.
For sure. Well, actually, to start this presentation, I should say that I am Nader. I am a researcher at University of Turku at the moment in Finland, and I am working on signal processing. And this research is related to a stock market prediction by combining convolutional neural networks and using multiple time frames. The Forex stock market has attracted significant research attentions during these years with various approaches that are employed for market analysis. Nevertheless, the traditional econometric models have proven inadequate in accurately predicting short-term trends. During this year's recent studies have highlighted the effectiveness of indicators to address this obstacle, such as the RSI and different types of moving average, such as RMA. And also, the researchers have explored the application of machine learning techniques and algorithms to improve stock market forecasting and trend prediction, such as support vector machines, PCA, K-nearest neighborhood, and different deep learning methods. Our suggested model that named multi-CNN extract key features from Forex market data to make accurate predictions and improve accuracy in Forex stock market analysis and forecasting. And this model shows excellent potential for improving trend strategies and decision-making in financial markets by providing accurate forecasting and insight into market trends. Well, this research includes several steps that starts from data gathering and processing the data, choosing the suitable loss function and activation function, and tuning the model, providing some benchmark models for comparativity with our model, and designing and comparison of results of multi-CNN with benchmark models. In fact, our data are related to euro to American dollar symbol in Forex in 3 different time frames of 15 minutes, 30 minutes, and 1 hour from January of 2015 to December of 2020. That we provide this data from a broker in Switzerland named Dukascopy.com. For normalization of the data, we use a harmonic mean, and also we tried other parameters from this data set, such as normal mean, standard deviation, and variance, but the best result was related to harmonic mean. And also we used a couple of loss functions named mean square error and FLF that, as I know, the idea of FLF is coming from MSE with some modifications. Well, as we know, RNNs have gained widespread popularity for discern patterns from sequential data and time series. Nevertheless, these models suffer from the limitation of memory capacity. So LSTMs with long short-term memory and solid state help to address this issue. And actually, GRU simplified the memory mechanism in LSTM for handling long-term information. And I think it makes sense that why people prefer to use RNN-based models for analyzing sequential data. Also, CNNs widely employed for 2-dimension and 3-dimension visual tasks like image classification or fMRI image analysis, but 1-dimensional CNNs utilized for sequential data and time series analysis. And in this picture, you can see that the filter of convolutional neural networks moves forward through the time series, through the time, and the calculated value of a part of data that filter is visiting them with special bias and weight put it into a new array as output of that layer. The incorporating diverse timeframes allow the model to capturing intricate hidden patterns inherent in sequential data, and particularly in time series analysis. And this is the reason that we use 3 different timeframes for training our model. The multi-CNN is composes of 3 separate neural networks with each network utilizes a pair of convolutional layers. That the first CNN layer is designed with 256 neurons, enabling it to extract high-level features from the input data. And the second layer with 128 neurons further refines the extracted features effectively by capturing the underlying patterns. And following these convolutional layers, a fully connected layer with 4 neurons is employed in each neural network that is responsible for predicting the values associated with open, high, low, and close prices that are our feature in financial data sets. And to consolidate the predicted values obtained from the different time frames and combine the CNNs, concatenation layer is employed that enable the fusion of informations. And finally, we have a fully connected layer that is utilized to predict the output value of the target time frame. In this slide, we can see the learning curves that the convergence of both training and validations loss curves shows that the model trained effectively. Here we can see that there are 6 different images. In the left side, we have a couple of images that are related to the diagram of the prediction of our benchmark models that are CNN, LSTM, and GRU, that each one of them includes 2 layers. And also the middle images are related to the diagram of predicted values of our model. And in the right side of the slide, we have a couple of tables that are related to the comparison between the different experiments and with using MSE and FLF loss functions and different activation functions, tangent hyperbolic, ReLU, and swish. And as we can see, the result of multi-CNN in all of these experiments are better than the benchmark models. This study introduced the multi-CNN model that is a novel artificial neural network architecture that surpasses traditional one-dimensional CNN-based approaches for Forex price prediction. And this model effectively reduces both mean square error and FLF value that indicates its ability to make more accurate predictions. Also, the multi-CNN utilizing cost functions consistently yields lower loss values compared to alternative models. This highlights that the effectiveness of the proposed model is minimizing prediction errors and capturing the underlying patterns in Forex price data. And at the end, thank you very much for this, for your attention and this Congress.
Thank you for presentation.
I appreciate that.
Is there any question? Okay, thanks again. Next presentation, dear Ikra.
Hello, am I audible at your end?
Hello, you can share your screen.
Yes, please hold on. Is the screen shared at your end?
No.
Please hold. Is it shared now?
Yeah.
Hello, my name is Ikra Javed, and I'm representing this work on behalf of Haris Said, who is one of my students and who performed as an opinion analysis of bilingual event data from the social networks. Actually, this study is regarding or basically aim at the bilingual study, or we have deployed different deep learning models on that. So these are the basic, you can say, sections of the presentation that I will consider today to represent. First, we will go through the introduction, later a little bit of related work, then methodology, which will be followed by result and analysis. And finally, we will discuss the conclusion and a little bit of future works data. So first of all, the aim of this study is to utilize the natural language processing techniques to analyze a data set extracted from the social network and performing the sentiment analysis using the deep learning approaches. Initially, let me explain that what is meant by sentiment analysis. That for this type of data, we have considered the data of political situation or political parties in the country, as this is one of the hottest topic nowadays in the country. So we tend to perform the sentiment analysis regarding different political parties. And in this state, we tend to categorize the sentiment as positive, negative, or neutral, which is represented by neutral was represented by 0 category, whereas negative was represented by 1, labeled as 1, and the positive one is labeled, positive tweets are labeled as 2. And later on, the training data used in the study, including the Roman Urdu language, comprises of almost 90,000 entries. Whereas the classification models were employed to categorize the emotions with the assembled techniques ultimately used to determine the results. These techniques involved LSTM as well as the BERT model, whereas LSTM gave us the accuracy of about 87% and the BERT model performed with the accuracy of 90%. The goal of the study is to determine what insights such as bilingual tweets can provide about Pakistani residents and how they see the political situation in an unbiased way. Next, I will discuss, it is worthy to mention a few related works. In the first one, the Azhar has centered approaches that have been worked on. So in the first approach, it is based on the centered on the machine learning problems of natural language processing, where they have employed support vector classifier models, which gives the accuracy of about 74%, and where logistic regression model was the highest, paying the accuracy of 75%. Though they have employed, excuse me, though they have employed the classification techniques like multinomial naive-Bayes and complement naive-Bayes models. Excuse me. Apart from that, the second technique that was proposed by Forward, which is actually a lexicon-based technique, and it also deployed on the dataset of Roman and Roman Urdu and English tweets, whereas they have identified a total of almost 3,000 positive tweets with accuracy of 81%, and the negative, almost 2,000 tweets have been identified with accuracy of 76%, and about 500 tweets were identified as neutral with an accuracy of 56%. Apart from that, Ved Afzal had also performed a lexicon-based novel technique, which was again used based upon the sentence strength. But their dataset was comprised to the Fervo was a little bit more. It was comprising of 92,000 tweets, whereas among 21,000 were non-political, and apart from political content, they do have 63,000 tweets as identified as English, and apart from this, in contrast to English one, almost 8,000 tweets were imparted as the Roman Urdu. The technique that they have used is the bigram cosine similarity metric, which tend to give the accuracy of 79% approximately. As well as the Samin have also performed some machine learning algorithms like SVM, logistic regression, random forest, and naive-Bayes using KNN as well. And they have actually give the accuracy of about the accuracy of their is 80% in case of when they SVM performed this in their case. So these are the similar or few works that we have studied before starting over. Our methodology was completely based upon, initially it was based upon that we initially get the data set containing the code mix Roman Urdu and English text, and for that we have used a Kaggle-based data set, as well as we have retrieved some tweets from the Twitter. Later, we have deployed LSTM and BERT models to categorize the sentiments associated with the content that we have in the dataset. And training of the models by varying the hyperparameters was also performed. Evaluation of the trained models using the FN score and accuracy metrics have been performed in order to see the clear picture. While doing the data acquisition, there were different tweets, the type of tweets related to different political parties have been collected, where this table 1 represents the number of tweets which collectively accumulate about Urdu about 90,000, 1,20,000, but after the novel or unique tweets have been collected, they remain about 87,000 tweets. And so is the case with the English, that the number of percentage of the tweets remain unique tweets were about 70% of the actual ones. Apart from this, the data table 2 represent the data description of the languages, that how many instances were there, like for example in Roman Urdu. Basically, our more focus was based upon the Roman Urdu, because there were no such techniques that have been deployed mainly on the Roman Urdu. So the number of instances, like 12,000, number of unique words that have been identified in the dataset were like 11,000. Minimum words were like 1, and the maximum word in a tweet were like 35. Whereas average number of the instances is about 16 in the Roman Urdu text. After performing the data acquisition, we went for the data pre-processing, where we remove the emotions, hashtags, and different mentions and other unimportant data. For example, like the stop words removal, the words with the strange symbols, and the normalizing tweets. After that, we went for the classification models, where we apply the LSTM and BERT model. LSTM stands for, as you know, that long short-term memory, where LSTM layer would therefore able to perform or represent the long-term dependencies in the sequence by capturing the temporal correlation between the input tokens. And the output of the LSTM layer would then be classified using the task-specific layer. The layer is composed of cells known as input, output gate, and forget gate, where the forget gate tend to help us out in the feature extraction and moving on to with the information that is useful for us. The input sequence is first fed into the LSTM cell. And the feature are then extracted by utilizing the LSTM model to extract the hidden state and each step, the length characteristics from the input sequence, and the capture that, for example, capture the necessary data for the job, and where the concealed state can serve as a feature representation of the input sequence. And when we are talking about BERT model, the BERT model is as we know that it is bidirectional encoder representation from the transformer. So it can read bidirectionally from left to right and from right to left. So it kept more information in contrast with the LSTM, in which actually is you can say depicted in the results as well. So as far as the BERT is concerned, we tend to input the first tokenize before being fed into the pre-trained model to extract the features using the BERT model, where a series of hidden states indicate the contextual connections between the input tokens and our model or output helps. Later on, transformers were also being involved, and it's not worthy to forget the transformers here. That encoders has two parts, like multi-head attention and feed-forward neural network, and then we also tend to tune the hyperparameters accordingly. As here we use the attention using the softmax layer with the dimensions and the dimensions of K and H, where K is the number of classes, and the hidden states like are based upon the BERT base, like which are 768 by default. So, and there were three classes which are considered in the intention, which is positive, negative, and the neutral one. Tuning of hyperparameters, we tend to use these parameters, like for BERT, we use the batch size of 4, whereas learning rate was 5 and number of epochs were 3. Unfortunately, when we increase the number of epochs, like 5 or so, there were no considerable increase in the accuracy and the results, but in fact, its performance getting down, so we have to leave that. Whereas in case of LSTM, we use the batch size of 32, learning rate was 5, as well as the number of epochs. We keep it to normalize it to keep the number of epochs 3 as well, because In case of increasing a number of epochs, the number of results was not considerably, it was in the decimals. As far as the training and evaluation is concerned, we have used to label the columns with 1, 0, and 2 for respectively for negative, neutral, and the positive one. Whereas the data distribution was like we have dedicated 80% of the data for the training, whereas 20% of the data was set aside for the testing phase. For the validation loader, we use the sequential sampler, which samples the elements sequentially in the same order always. And after that, we set the model hyperparameters. The model is trained in the training loops. And the model is being trained. The outcome for each epoch, such as training and training loss and training accuracy, are being saved at each epoch and so on. So the table for the tuning of hyperparameters are being shown. And as far as the results and analysis are concerned, the results were, or the model accuracy and F1 score have been used for the cross comparison of the both models, where accuracy of the LSTM was observed as 87%, and BERT gave us the accuracy of 90%. And same as the F1 score for LSTM was 87 and BERT stands 91. So in all cases, BERT actually beats the LSTM. So conclusion and future work, after comparison, the model outputs based on accuracy and F1 score. It is recorded that the data and adjusted the main hyperparameters of the models. The outcomes demonstrated that BERT model beats the LSTM for code mixed languages with a wide range. Of course, in this case, it had the capability of keeping the forward and backward words over the whole content in the bi-directional way in its memory. So BERT beats the LSTM in terms of performance as well as the accuracy. So these are our findings in this case, and BERT is now better to handle lengthy text sequences and recognize more complex word relationships, whereas in contrast, LSTM uses the recurrent connections to handle data sequences, which can be less efficient over time. And in some case of sequences. Though in terms of feature work, if we get to know any API for the distinction or which can easily classify in between the English and Urdu words, because in English, in most of the tweets, we tend to see the words which are which have dual meanings. The words that have some particular, the tokens have some meaning in English as well as in Urdu. So in that particular cases, we have to be we have to use the threshold that above this threshold, if the word number of words in the tweet or the content is like this, is above like 68%, then we will moving it towards the Urdu, Roman Urdu tweet, or else it was in the English trade. But there is no, but this criteria doesn't have any logical standing, but it was considered as to set up a threshold in between. These are the certain references that I have mentioned. Any question? Thank you.
I have a question, please.
Yes, please.
Could you please turn back on hyperparameters table?
Yes.
Sorry, I didn't understand why you use just 3 epochs for training your model.
I have mentioned in the presentation that when we were, unfortunately, the reason was the data size was quite big enough that whenever we were moving, you can say beyond 3, when especially, so the results were not improving that much. But unfortunately, when we use number of epochs beyond 5, the model was actually crashing at our data. So that was the reason that we restricted it to 3, because it wasn't adding any much value to the project, to the you can say findings.
Okay, thank you.
Welcome.
Thank you for presentation.
Thank you.
Next presentation, dear Omar, Omar Mohammed.
Yes, Omar. Omar what?
You can share your screen.
Omar Al-Harsis, right?
Yeah.
Okay, just a second. Can you see my screen?
Yeah, no problem. You can start.
Okay. Next focus. Okay. So, good day, everybody. My name is Omar Al-Harsis, a PhD student at Budapest University of Technology and Economics at the Faculty of Transport Engineering and Vehicle Engineering in the Department of Aeronautics. Today, I'm going to present to you my topic entitled Evaluating AI, Artificial Intelligence Powered UAV System using combined approach with operator group comparison. So let's begin. As you can see here is the outlines of my presentation, starting from the motivation of this research, just a brief literature of the chosen research, and we will also talk about the methodology and concept using specific models in human factor rule. And based on that, I will discuss about the questionnaire which has been built and highlight the most important results mathematically and graphically. And some concluding remarks will also be presented, and lastly, some references, of course. So let's start. When we say autonomous UAV or artificial intelligence UAV, of course, we mean that unmanned aerial vehicle, which is powered by artificial intelligence, or could be have the ability to make some decision-making process by itself to a specific limit. And of course, it has revolutionized the industry. Different perspective of industry has been revolutionized by the ability to make decisions and operate without some human intervention. But does that mean we have to eliminate the human? No, of course. In fact, the autonomous UAV have enhanced a lot of examples in surveillance, delivery services, search and rescue missions, improved also decision-making, efficiency, and safety. Although all the regulations in the airspace have one common goal, especially in the UAV, minimizing the risk to other airspace users and to both people and property on the ground, human factor is still a critical factor in the current situation. So even in the era of UAV, we have some human rules to ensure safe and efficient operation. When we talk about the human factor, we mean elements such as human cognition, decision-making, situational awareness, and intervention capability. Now, the operation or the UAV operator is changing from control or active control to oversight and only control in necessary or emergency situations to mitigate the risk, of course. The research tried to introduce a novel methodology here using human factor analysis and classification system for accident prevention, and also the observe, orient, decide, act loop to combine it with analytical hierarchy process, AHP. Very fastly talking about the literature, why we choose these models. For the Department of Defense in the USA has been successfully employed the human factor analysis and classification in the UAV system and prevent a significant percentage of incidents using it in the UAV system. And that means that it is a very powerful tool to use in the UAV system, even the autonomous UAV. And the observe, orient, decide, act loop is a concept developed by the military strategist John Boyd, decision-making in complex. In fact, it is about the complex and rapidly changing situation, which fits here for the UAV, especially with the artificial intelligence powered UAV. And since it has some ability to decide in situation, so it's good to oversight or supervise the OODA loop in the UAV system. Now, why we use the AHP methodology? Because there are many examples of using the AHP in the UAV. One of them is employing the AHP in the operation of assessing UAV training system based on visual simulation by Ting in 2018. And another significant usage here is the safety and security for decision-making support model for the UAV disaster response for using AHP and TOPSIS method. Both of them are multi-criteria decision-making methods. There are many other studies highlighted the usage of those methodology, especially in using the multi-class decision making or others, especially for AHV also. When we talk about the unmanned aerial vehicle, we mean also commercially known as a drone. It's operated by a human pilot, no human pilot on board. However, it could be remotely controlled or autonomous, which we here focus on. First appearance in the Second World War. Also, there are a lot of agencies that are responsible for the licensing system. As we can see here from the videos, the human factor is always considered in the system. Some events could have some injuries for human factor to be involved in, or even the expensive tools that could be destroyed using the UAV. So we need to unify the licensing system in the UAV. Our methodology here, the objective of the methodology, trying to assess and evaluate and investigate or incorporate the UAV system by assessing the human factor and investigating the causation of the accident and incorporating the OODA loop. Now, to do this, firstly, we need to categorize the operator based on the license, based on the skilled, of course, skilled based on the experience. The PCC was based on a 3 years experience, if UAV operator has a 3-year experience or not. And using these methodologies or these models, concept models, we created a hierarchical model to make a systematic approach for them and to make it able to compare the relative importance of different elements within each model and for each level. So we utilize both of the human factor analysis and the classification system and the OODA loop in the autonomous UAV using the AHV methodology. Here we can see that before we start for the models, I need to highlight that in the AI-supported UAV, we comprise 3 main dimensions: the design, human factors, and operation. In the design, which involves the integrating of technical requirement or technical requests, like hardware, software, AI algorithms. And when we consider a human factor, that of course it is the impact of assessing the impact of operators and including the cognitive and psychological, physiological effects on shaping the human machine or human autonomous system interaction, which is what we're trying to do here. And of course, lastly is the operation, which is the regulation, safety, consideration, and emergency procedures. But why we are doing this? We are trying, the importance is optimizing importance here is to optimize the performance, enhance the human operator interaction, and to mitigate the risk in the future. And of course, implication will be for advancement in the design, and this because of the reshaping of the human factor rule in these systems and the operation for the AI-supported UAV. For the human factor analysis and the classification, as you can see here, it's a widely used framework for analyzing the human factor. And this model comprises 4 levels for accident prevention: unsafe acts, precondition for unsafe acts, unsafe supervision, and organizational influences. In the context of AI UAV, unsafe acts represents human operator action. Precondition for unsafe acts capture the impact of AI on operators, cognitive loads and psychological state. And unsafe supervision reflects the impact of AI on vigilances and trust. And of course, the lastly is the organizational influences, which shows the regulatory framework that are used to based on the licensing system or agency. And of course, this framework enables to identify the factors contributing for human errors in the operations, and of course, develop and mitigate the strategies. The second model here, which is the OODA loop, as you can see, the detailed OODA loop, it's a decision-making model. As we mentioned that before, it's widely used in the military operation and could be considered in the UAV system, and consists of 4 main steps: the observe, orient, decide, and act. It enables a rapid decision making by collecting relevant information and analyzing it. Of course, making decision implement in the AI UAV operation, the OODA loop can be employed using the sensor data, the algorithms, AI algorithms, and the control system of UAV. And this allows the UAV to make quick decisions in the dynamic environment, which is in the autonomous UAV here, and also enhancing the operational performance. And there is a problem here, is the with also the increase of the autonomous, there is an increase in the cognitive load of the UAV operator, and which they have to monitor the AI decision making. And here we're trying to fill the gap. And you can see here the four steps of observe, orient, decide, and act. And how if each one of them, for example, in the observe, there is some inputs based on the circumstances, based on the environment, surrounding environment, also in the outside information, in the outdated information, and it will come from what feeds it back from the previous operation. Then it goes for the variant, which here mostly is the AI algorithms, and based on the algorithm itself, it could give a hypothesis, and then the decision for this hypothesis, which is in the decide phase, and based on it, there will be an action. Now, based on these models, we have in the realm of the autonomous UAV or AI UAV, the integration of AHP methodology, analytical hierarchy process, with the OODA loop and the human factor analysis and classification framework, which plays a crucial role here in assessing and evaluating the human factor. The methodology was to create a hierarchical systematic evaluation for decision making for the operators. So we're trying to make the human factor reflect their opinion in the system based on these frameworks on the human factor analysis and the classification, and based on the OODA loop. As you can see here is the hierarchical models. And based on it, we created this hierarchical model. From this hierarchical model, of course, we created the questionnaires based on the hierarchical model. And this questionnaire was based on the analytical hierarchy process. So what we are trying to aim to evaluate, or to give to evaluate these elements, and can give comprehensive visions of the interaction between the autonomous UAV and the operator, and could also include the performance, workload, decision making. This assessment could be vital in the optimizing the design, operation, and safety, and enhancing the human-operator interaction, mitigate the potential risk in the autonomous UAV domain, and facilitate a deeper understanding for the interplay between the AI and the human factor. Okay, the next one. Based on the hierarchy, we have created an AHP-based survey, online AHP-based survey for both for each one of the models. And of course, here in the presentation shows that there are 20 UAV operators from different countries have been participated, but now we have more. And also have been categorized. The first categorization, or the first step, we could say that categorizing based on the legal system, because we mentioned that the license agency is important. So it's important to know that which UAV operator is licensed and which one is not licensed, and also the experience based on the 3 years of experience. We categorize them, and also we give them the ability to categorize of self-categorization if they feel like they are experienced or not experienced. And as shown here from the pie graphs for the skilled, non-skilled, and for the licensed, non-licensed, and also the countries, distribution of the countries. Also, it's very important why we consider the countries, because the geographical distribution shows different licensing system, and we need to show the difference between licensing system of each countries. And also we consider the job sector, which is very important here, because the aim of using the UAV will be depending on the job sector that the aim that they are using for, of course, or the purpose that they are using for. We consider 7 job sectors: commercial, surveying, engineering, security, transport, and agriculture and material, military. And based on this questionnaire and this information, of course, we created the questionnaire, we applied the analytical hierarchy process. But for the next slide, okay, we used the SATI scale, which why we use that scale? Because it gives a high degree of freedom to evaluate the opinion from 1 till 9. As you can see here, the scale gives 1 gives an equal importance of each element, and 9 gives an extremely important of one element over another. In the bottom of the slide, also I show an example using the comparison between decision error and skill-based error. In the person's opinion here, if taking 5 from the decision error, it shows that the decision error is strongly important than the skill-based error. Of course, this opinion has been reflected in from an opinion to mathematical representation. And then this mathematical representation will be used to create the pairwise comparison matrices, as we can see here. So the analytical hierarchy process allowed us to evaluate the criteria and sub-criteria of each element using the models concept of human factor and the classification system and the OODA loop. Here is for the OODA loop, as you can see, for the first criteria. And the finding here reveals the preferences order and scaling for the loop for using the AI UAV operation based on the participating operator. and the AHP response procedure, which shows the critical factor for each level and gives a reliable indicator for the important aspect. Here, for example, the experience level influence the prioritization of ODA loop phase in one group, which emphasizes the comprehensive decision making, decide phase, while the other group prioritize the immediate response, active group. So this discrepancy is important. Why? Because it shows the aim of using the AHP methodology, and it's assigned weighting numbers to them, weighting. So ranking and weighting and evaluating is very important in that case. The same here is for human factor analysis and classification system has been used, and we can see the differences even in the first layer, in the first ranking. We see that based on the license system here for the UAV operator, one of them have prioritized the organizational influences. However, the second one prioritized the unsafe acts. Now, graphically, if we go further for graphically in the ODA loop, we can see the difference here. In the first level, almost similar opinion between the operators. If we go to the second level, we can see difference in the act sub-criteria. We can see difference in the opinion, which focuses based on the expert group. And also, if we consider a different categorization, as I mentioned before, for example, if we mention the 7 job categorization, we can see 7 different categorization and discrepancies among them between each group regarding the 4 main criteria of the group. It's still obvious that that they are prioritizing the immediate response, the act phase, and the most important one, and the dominant, which should be considered in the operation during the human factor rule, which is changing in the supervision, and influence, and it is influenced by the situation awareness as well. Now, for the human factor, also the same is shown here for licensed and non-licensed, and also for the experienced and non-experienced. You can see that here there are some discrepancies shown based on the categorization. Experience may focus more on the organizational influences. However, the non-experienced may focus on unsafe acts. The same here for licensed and non-licensed. However, we can see also the unsafe acts is very important. Even considering the seven jobs categorization, there's show a lot of discrepancies. And for example, engineering drone operator focus more on the organizational influences. However, the military drone operator focus more on the unsafe acts, and agricultural drone operator focus more on the supervision. So, but we can give an average overview of these. Basically, most of them, they're focusing on organizational influences and unsafe acts. So basically, what we are trying to conclude here, that human factor analysis and the classification system and the ODA loop models are crucial for the assessing and optimization of the AI-supported UAV operation, and could capture the visions and discrepancies among the UAV operator. Also, using the AHP analytical hierarchy process is very important, and it enables the hierarchical evaluation of the component. We could consider that unsafe acts and organizational influences is critical for the human factor analysis and classification. And in the framework of ODA AHP assessment, we have seen the importance of the proactive action and decision-making for error prevention. We also need to highlight the necessity to unify the AUV system, licensing system, and addressing the training gaps between different geographical and agency in different groups worldwide. We also have to state that even in the age of autonomous vehicle or autonomous UAV systems, we cannot eliminate the human factor. However, we are reshaping it from active control to passive supervision. And also it should be involved in the safety of the UAS system. Very fastly, I want to mention about our future work. The current author are now started with initiating the use of ECG device for measuring the vital parameters for UAV operator. We are using measurement conducting during different operational scenarios with different level of autonomy, and we are implementing utilizing the using of DJI Mavic 2 Enterprise for data collection. The measurement aim to evaluate the psychological, physiological response of operator during the operation of different autonomy level. and it will provide some insights for operator performance, workload, different type of loads of mental load, task load for operator, and also will contribute in development of optimizing the operational practice for human-machine interface and autonomous UAV. Here are some of the most important references, and I hope you understand everything. Thank you for your attention. Any questions? Very welcome.
Thank you for presentation.
Thank you.
Is there any question? Thanks again.
Thank you. Thank you very much.
Next presentation, dear Abdul Kuyum.
Yes, I'm here. Assalamu alaikum. Can you hear me?
Yeah, you can start.
Can you see my presentation?
Yeah, no problem.
Hello everyone, my name is Abdul Kayum. I'm a student of East West University. I'm going to represent our paper. You can see our title is Contextual Bangla Next Word Prediction and Sentence Generation using Bidirectional RNN with Attention. So here is the overview of my presentation. First, we will see the probability statement, then we will have a block diagram. Then we will see the tokenizer method we have used, then our proposed approach, then result analysis and implementation of the, then we'll see the interface of the implementation of our model, and finally the conclusion and future work. So for the probability statement, as you already know, in recent years, there has been a demand for natural language processing techniques that can accurately predict the following word in a phrase. Existing Bangla next word prediction system have significant drawbacks, including the inability to predict outside of their library and lengthy training cycles. So as a result, the output of those models gives us slow process and they are time consuming and very redundant. To address these issues, limitations and issues, we present a bidirectional language short-term memory with set attention method. So here is the whole a block diagram of our whole process. So for addressing these limitations, first we have collected some data set and we have cleaned those data set, and then we have tokenized our data set. Then we have trained then we did the model training part. Then we give some input. The input part get to the tokenizer model, then the tokenizer generates some sequences, and then they goes to our train model, which predicts the next sequence number, and then the tokenizer model again detokenize for us and give us the output. And for the data collection part, we may, as there is no previously made data set, we have made our data. We have collected our data from many Facebook groups. Basically, those Facebook groups have many stories and poems in Bangla language. We have collected from those groups. So as in word, we have collected total 364,929 words, and in this we have total unique words of 8,675. This is the overview of our dataset process. First, we have collected dataset. Then, using a cleaning function, we have cleaned our dataset. Basically, we have removed the punctuations, unnecessary words, like unnecessary letters, other than Bengali letters. We have removed all other letters and punctuations from our dataset. Then we divided our dataset into gram dataset from by gram to 7 gram. That means we have used one word, 2 word, up to 7 words, 6 words. For the tokenization, we have used the word to vector model. Word to vector model have 2 different algo. One is SIBO and skipgram. We all know word to vector model does the tokenization method does convert a text into numerical value and convert a numeric value into text.
So for our proposed approach, we have used the water vector CVAO algorithm. So here you can see the overview of our creating the water vector model for different gram data set. We have created 6 different water vector for 6 different gram model. Here is an example of our water vector model in CVAO algo. Here we have tried to find a similar word of Akash, which means sky in English. It's showing that Akash have the water vector showing the similar word of Gogon, which is a similar word of Akash, and Asman, which is also a similar word of Akash. These are the which have the highest accuracy, which we are looking for our proposed approach. These words are the most related words to this Akash. And similarly for Ogni, which means fire, we have similar words like Onol and Agun. For here is a example of our tokenization with water vector. We have input 4 words here, which tokenized into 4 different number of sequence. So for the proposed approach, we have used the ngraph language model. Then we used it in deep learning approach with attention mechanism. So why we have used up to 7 gram model? Because in long sequence of text, next word dependency mostly depends on the last 4 or 5 consecutive words. So for our proposed approach, we have used a BiLSTM structure. Here is a BiLSTM structure. Then this is the structure of our train model. The embedding layer, the input layer, then comes the embedding layer, then bidirectional LSTM layer, then the attention layer, and finally the dense layer. So for attention layer, we have used the self attention mechanism. We get this number of we get these vectors from this bidirectional LSTM layer. Then we convert these vectors into 3 different linear layers, which keys, queries, and values. These keys and queries, we have done matrix multiplication with keys and queries values, which creates some score value. And then we normalize this score value that becomes a weight. And finally, the value we have matrix multiplied the these weights with the values, and we again get similar type of vectors. This, what does the self-addition mechanism does? It add more context to those number vectors or the words, so which helps to learn more. Basically, we all know that any deep learning model have a tendency to forget at it after some time. So adding a context using self-attention mechanism help us our model to remember the sequence of words more. Using our proposed approach, we have some excellent result. As you can see, only using 200 epoch, we have gained accuracy up nearly 100. It was nearly 97% for the higher gram models. And for 2 gram models, it is very low because the 2 gram models have many repeated words at a time. And as you can see, for the loss model, our loss also very low. It's almost near to 0. And you can see it only we get this result only using 200 epoch. So the percentage of our accuracy for bigram model, we have get 39.39%, and trigram model 90.33%, 4 gram model 97.38%. For 5 gram model, we have got 97.91%. 6 gram model 97.97%, and 7 gram model 97.98%. And for the loss, we have for diagram we have 2.28, trigram 0.23, 4 gram 0.07, 5 gram 0.06, 6 gram 0.06, and 7 gram 0.06. After that, we have test accuracy of our model based on Rouge score. We all know that what does the Rouge score does. Basically, it compares the actual sentence with our we have actually what we have done that we compared our generated sentence with the actual sentence from our data set, and here you can see the scores from that. So you can see that for 7 gram we have get the most highest accuracy here. For there are some related works like ours. So we have added 2 paper name here. As you can see, both of these paper approach was based on word prediction of Bangla sentences by using an n-gram language model. But there was a limitation. They have a probabilistic view and higher memory for bigger data set. And another paper was very similar to our work. They used RNN to upgrade the n-gram model. Every time helps the probability to get more accurate result. Their work within 5 different data sets having sequential data. For their accuracy, in this pair, the textual word prediction system gives an average accuracy of 99.70% for 5 gram, 99.24% for 4 gram model, and 95.84% for 4 gram model. And there are some other accuracy for trigram model 78.15% and 32.17% for bigram model. As you can see, they have achieved this result on average on 1000 epoch. So their limitation is this system does not work well with large data set. Unigram model, which basically in our paper is bigram model. Their unigram model gives poor accuracy for their system, like 32.17%, where our accuracy was 39.39%. And their models are overfitting. So here is a comparison table with us and other 2 papers. The blue one was from our papers, and the orange and the ash gray bars from other papers. As you can see, for bigram, trigram, 4 gram, 5 gram, for up to 4 gram model, we have exceeded their accuracy. But for 5 gram, we are nearly their accuracy. But why we cannot exceed that? We can say that we have only trained our models for 200 epochs, but the other 2 paper, they have trained their models up to 1000 epochs. We can estimate that if we train that longer time, we may have get to their accuracy also. So here is an example from our model. So you can see we have entered 4 words. Our model showing the next word with their similar words. Here we have added the 5 words, and our model generated the next word, and these two words are from most similar word from of this word. So conclusion and future work. Bidirectional LSTM with attention, notes of the contribution outperforms other approaches. Increasing input length improves accuracy significantly. Impressive result and broader application potential for larger dataset, aids sustainable technology. For future works, larger dataset for improved performance. As you have already saw, we have used only 390,000 word, something like that. We want to use more data to train our model. Enhance word completion and sentence synthesis, improve performance in these areas. We want to train our model with different kind of sentence and different kind of words to made our model far better than other ones. Broaden application areas. Explore a wide range of practical application. So here is some references I have used in my presentation. Thank you, everyone.
Thank you for presentation. Is there any question? Thanks again. Next presentation. Dear Shaima. I'm not online. Dear Yaser. Yaser Amer. Dear Yaser, can you hear me? Dear Ahmet Seyfullah Güneş.
Buyurun hocam.
Hazırsanız size devam edelim.
Hocam. Ekranım gözüküyor mu?
Geliyor, problem yok.
Öncelikle herkese merhabalar. Ben Ahmet Seyfullah Güneş. Bursa Teknik Üniversitesi Mekatronik Mühendisliği Bölümü yüksek lisans öğrencisiyim. Danışman hocam Saffet Vatansever ile birlikte yazdığımız bu makalede, yani bu çalışmada medya adli bilişiminde elektrik şebeke frekansına dayalı uygulamaları inceledik. Bu konu, bu sunum altında bahsedeceğimiz konular INF nedir? INF kestiğim metotları, INF referans sinyali elde edilmesi, medya dosyalarının INF tabanlı adli analiz uygulamaları, INF potansiyel kullanım alanları ve en sonunda sonuçtan bahsedeceğiz. İlk bahsedeceğimiz konu INF'in ne olduğudur. INF elektrik şebeke ortalamasının frekansıdır. Elektrik şebeke frekansını belirleyen faktör, elektrik üretiminde kullanılan türbinlerin dönüş hızıdır. Nominal INF Avrupa'nın çoğu yerinde 50 Hz iken Amerika'da ise 60 Hz olarak ölçülmüştür. Burada kullandıkları türbinlerin dönüş hızının farklı olmasından kaynaklanıyor. INF nominal değeri etrafında anlık dalgalanmalar yapar. Tüm elektrik şebeke üzerinde INF sinyali benzerdir. Ve şebekeye bağlı cihazlarda kaydedilen ses ve videolarda bu INF sinyali tespit edilebilir. INF kestiği metotları. Bu başlık altında video kayıtlarında, ses kayıtlarında gömülü olan INF sinyalinin nasıl tespit edilebildiğini, bunların kestiği metotlarını inceledik. Bunlar kısa zaman, bu konu başlık altında incelediğimiz metotlar kısa zaman Fourier dönüşümü, çoklu sinyal sınıflandırılması yani müzik metodu, rotasyonel değişmezlik tekniğiyle sinyal parametrelerinin kestiğimi yani esprit metodu ve sıfır geçiş yöntemidir. Zero crossing metodu. INF kestim metotlarından olan kısa zaman Fourier dönüşümü parametrik olmayan bir yöntemdir. Buradaki temel prensip bir sinyali frekans ve faz bileşenliğinin zamana bağlı değişimliği hesaplanır. Bu yöntemle sinyal sabit aralıklarda bölünür ve her parça üzerinde Fourier dönüşüm uygulanır. Şekilde de bunu gösteriyoruz zaten. Ses sinyallerinin spektrogramlarının oluşturulmasında kullanılır. Diğer yöntemlere kıyasladığımızda daha hızlı bir yöntemdir. Bu şekilde de giriş sinyalini görüyoruz. Burada örnek seyyeltme metoduyla ve bant geçiş filtreleme devre filtresinden geçiriyoruz. Bunları parçalara oluşturuyoruz. J kadar pencereye bölüyoruz. Bunların her biri örtüşüyor birbiriyle. Üzerlerine fast Fourier transformu yaptıktan sonra maksimum genliği tespit ediyoruz. Kuadratik interpolasyonla da kestiğimi yapıyoruz. INF kestiğimi yapıyoruz. Bir sonraki metodumuz ise Multiple Signal Classification yani müzik metodudur. Bu parametrik bir yöntemdir. Medya dosyasını birden fazla sinyal alt uzayından oluştuğunu varsayar. Medya sinyalini sinyal alt uzayı ve gürültü alt uzayı olarak ikiye ayırır. Ve gürültü alt uzayının ortogonallik özelliğine dayanır. Yüksek çözünürlüklü sonuçlar verir. Burada akış diyagramında gördüğümüz gibi giriş sinyali geliyor, korelasyon matrisi hesaplanıyor, özdeğer ayrışımı gerçekleştiriliyor, müzik spektrumu hesaplanıyor, tepe noktaların en büyük olduğu noktalar kestiriliyor, INF sinyali kestiriliyor en sonunda. Bu metodun dayandığı nokta gürültü alt uzayına incelemesidir. Bir sonraki inceleyeceğimiz metotta medya sinyaline ait olan alt uzaya incelemektedir. Parametrik bir yöntem olan esprit metodu yani rotasyonel değişmezlik tekniğiyle sinyal parametrelerinin kestiğimi medya sinyalini sinyal alt uzayı ve gürültü alt uzayı olarak ikiye ayırıyor. Sinyal alt uzayının rotasyonel değişmezlik özelliklerini analiz eder. INF sinyallerini özdeğer cinsinden bulur ve müzik metoduna kıyasla daha az ve yükü taşıdığından daha az işlem gücü harcar. Burada işte yöntemin işleyişini görüyoruz. Giriş sinyali korelasyon matrisi hesaplanıyor. Özdeğer ayrışımı gerçekleştiriyor. Esprit spektrumu hesaplanıyor. Tepe noktaların en büyük oldukları noktalar kesiliyor ve INF sinyali kestiriliyor. Son metodumuz ise bu çalışmamızda incelediğimiz sıfır geçiş yöntemi yani zero crossing metodudur. Bir time domain yaklaşım metodudur. Zaman etki alanı üzerinde bir sinyalin sıfır noktasından geçişlerine bakılır. Sıfır geçişlerinin sıklığı frekans sinyalini verir. Temelde giriş sinyali örtüşmeli sinyal parçalı pencereyi oluşturuluyor. Her pencere için spektral kestiğimi hesaplanır. Sıfır geçişleri hesaplanır. Sıfır geçiş sıklığına bakılır ve INF sinyali kestirilir. Şimdi medya dosyalarından INF sinyali elde edilmesini gördük. Şimdi ise bu analizlerde kullandığımız referans sinyalinin elde edilmesine bakacağız. Çünkü bir medya sinyalinden alınan INF sinyali tek başına çok bir işe yayamaz yani yöntemlerimizi kullandığımızda. Bazı işleyi vardır. Ancak bir referans sinyalle karşılaştırmaları gerekir ki sonuç elde edilebilsin. Referans sinyali medya dosyaların analizinde kullanılır. Şebeke verilerinin kaydedildiği açık kaynak merkezlerini elde edilebilir. Yani ülkelerde, illerde elektrik dağıtım şebekelerinde bu elektrik şebekesine ait veriler saklanır. Buradan INF sinyallerinin referansları elde edilebilir. Ya da şebeke üzerine bağlanacak bir elektrik devresiyle bireysel olarak da kaydedebilir. Şebeke frekans sesini kaydederek bunu bilgisayara aktarır ve oradan INF sinyali elde edilebilir. Şimdi medya dosyalarının INF tabanlı adli analiz uygulamalarına geçiyoruz. Ne tür uygulamalar var dersek dosya kayıt zamanı tespiti veya doğrulaması yapılabilir. Coğrafi konum tespiti yapılabilir. Çoklu ortam dosyalarının senkronizasyonu yapılabilir. Modifikasyona uğramış içerik tespiti yapılabilir. Ve başka ufak daha üzerine çalışılan uygulamalar da var. Onlar da yapılır. Yani delil kaydetme uygulamalarının tespiti, mikrofon ve kamera cihaz tespiti, ses kaydı kurtarma, şebeke içi konum tespiti gibi uygulamalar da yapılabilmektedir. Dosya kayıt zaman tespiti veya doğrulaması başlığını biraz daha detaylı inceleyelim. medya dosyasından aldığımız ENF sinyali ile referans sinyali normalize çapraz korelasyona sokulur ve benzerlikle alınır. Burada rho max benzerliğin maksimum olduğu, L max da uzunluğu temsil eder. Rho max'ın eşik değerini aşıp aşmadığına bakarız. Burada bir eşik değeri belirlenir. Eğer bu eşik değeri geçilmişse sonuç çıkmaz. Yani bir tespit yapmak pek mümkün olmaz. Eğer doğruysa referans ENF sinyalinin başlangıç zamanına TR0'dayız. Bunu L max'ın uzunluğuna toplarsak kayıt zamanı elde etmiş oluyoruz. Burada referans sinyali alındığında yani ENF zamana bağlı eşsiz bir yapıda olduğu için hangi zamanda hangi karakteristiği sergilediği tespit edilebildiği için kayıt zamanı tespit edilebiliyor bu sayede. Coğrafi konum tespiti. İyi bir sunumumuzun başında her şebekede aynı özellik gösterdiğini söylemiştik. Her şebekede farklı, yani şebeke içerisinde aynı özelliği gösteren ENF sinyali şebekeler arasında eşsizdir. Yani bir şebekeden alınan ENF sinyali başka bir şebekeyle kıyaslandığında farkları ortaya çıkar. Burada yaptığımız çalışmada da K kadar şebekeden alınan ENF sinyali her biri medya verisiyle korelasyona sokulur. En yüksek rho max değeri hesaplanır. Yani korelasyon değeri hesaplanır. Bu rho max değeri eşik değerini aşıyor mu ona bakılır. Geçmiyorsa sonuç bulunamaz. Hangi şebeke tahmin edilemez. Eğer geçebiliyorsa maksimum korelasyonun tespit edildiği şebeke medyanın kaydedildiği konum olarak tespit edilebilir. Diğer konumuzda çoklu ortam dosyalarının senkronizasyonu. Bu burada bahsettiğimiz şey aynı konumda aynı objeyi kaydeden iki cihazın verilerinin birleştirilerek daha geniş bir alanı kapsayan bir görüntü verisi veya ses verisi elde edilmesidir. Burada yapılan iki kaydımız olduğunu ele alalım. Kayıt 1'in kayıt 2'den daha önce başlayıp daha geç bittiğini, yani kayıt 2'yi kapsadığını düşünelim. Bunlardan aldığımız ENF verileri normalde çapraz korelasyona sokulur. Rho max ve uzunluk hesaplanır. Maksimum korelasyon hesaplanır. Sonrasında kayıt 1'in başlangıç zamanı T1 0'deyiz. Burada rho max'ı topladığımızda kayıt 1'in L rho max T1 0 saniyesinden itibaren kayıt 2'nin uzunluktaki klip ile alınıp kayıt 2 ile senkronize edilmiş olur. Bu yöntemle iki medya dosyası ses veya medya ses dosyası birleştirilebilir ve daha geniş kapsamlı bir medya verisi elde edilmiş olur. Modifikasyona uyanmış içerik tespiti. Burada da üzerinde oynama yapılıp yapılmadığını kestirmek için medya verileri incelenir. Medya verisi segmentlere ayırıyoruz bu yöntemde ilk başta. Her bir segmentten üzerinden ENF sinyali kestiğimi yapılıyor. Bu ENF sinyalleri bu aşağıda temsili ENF hesabı yapılır. Temsili ENF sinyallerinin örnek bazlı ortalama veya örnek bazlı medyan değerleri hesaplanarak bulunur. Bu temsili ENF ile her segmentten alınmış ENF sinyalleri normalize korelasyona sokulur ve maksimum korelasyona bakılır. Eşlik korelasyon her bir segment için alınan korelasyon değerlerinin eşik değeri geçmediğine bakılır. Eğer eşik değeri geçilmiyorsa o zaman o segmentlerde oynanmış olabilir diyebiliriz. modifikasyona uğramış aynı yöntemin başka bir işleyiş tarzı da referans INF sinyaliyle tespit edilmesi, bu medya verisindeki oynanmanın tespit edilmesi. Yine segmentte aydığımız medya sinyalinin her bir segmentinden INF kestiğimi yapıyoruz. Medya kaydının alındığı aynı zaman aralığındaki referans sinyaliyle korelasyona sokuyoruz. Eşik değeri korelasyon değeriyle eşik değerine bakılıyor. Eğer eşik değeri küçük gelirse, yani korelasyon değeri eşik değerinden küçükse, o zaman segmentlerde oynanma yapılmış diyebiliyoruz. INF'in potansiyel kullanımı. Şu an bu INF sinyali analizleri hala gelişmekte olan bir yöntem. Adli vakalarda kullanımı, sosyal medya platformlarında kullanımı, haber platformlarında kullanımı gelecek potansiyel olan bir yöntemdir INF sinyali analizleri. Sonuç olarak bu çalışmada medya dosyalarının INF tabanlı adli analizi kapsamında INF sinyallerinin literatürdeki analiz yöntemleri, mevcut uygulama alanları ve potansiyel kullanım alanları incelenmiştir. Gelişen teknoloji ile birlikte veri sahteciliği de büyük gelişmeler göstermiştir. Bu yüzden oluşacak tehditlere karşı önlem veya tespit amacıyla halihazırda kullanılan INF analiz yöntemleri gelecekte daha pek çok uygulama ve kullanım alanlarında kendisini gösterebilecek bir potansiyele sahiptir. Teşekkür ediyorum.
Evet, sunum için teşekkürler.
Hocam.
Next presentation, dear Yasir Amer.
Good afternoon, Dr.
Good afternoon. You can share your screen.
Okay. Did you see my presentation, Doctor?
We can see you must open presentation. Yeah.
Did you see it? Okay, Doctor. My name is Yasir Ahmad Jassim. This is my presentation. Good afternoon, everybody. This is about a 10 gigahertz printed circuit antenna for wireless power transfer applications. Introduction. Antenna terminals are considered one of the most important components in the wireless communication system. This is due to their ability to transmit and receive wireless electromagnetic waves to long distance. The electromagnetic waves can be transmitted to long distance by using antennae that have attract many research for many applications. Therefore, antenna with good performance can always facilitate wireless propagation with high quality and simplified architecture. One of the most attractive wireless propagation applications is the wireless power transfer through antenna terminals. However, certain limitations with antenna performance, including low gain, small bandwidth, low energy supporting, limited in the use of antenna in the wireless power transfer. Therefore, several types of technology involved to enhance the antenna performance, including metamaterials, MTM, and electromagnetic band gap EBG layers. This is a few types of antenna which is used to power transmit. Problem background. Due to the urgent needs for high gain antenna design that suits for application of modern system, MTM and EBG were proposed for such deployment. Currently, many countries applied the use of the power transfer system to do their enhancement performance include a high gain enhancement and support different application. Therefore, this development was invited as urgent generation to support these types of applications using millimeter and sub-6 gigahertz bands. Because many systems currently apply the use of the wireless technology, the antenna still suffers from different limitations. This is why currently many researchers apply the use of antenna performance enhancement using MTM and EBG layers. A high gain antenna design is operate microwave device based on active electromagnetic and realizing a real-time process. In one physical structure becomes one of the most urgent need in the modern technologies. Antenna performance is enhancement with EBG introduction. However, result EBG suffers from two fundamental limitations. Narrow bandwidth, over which is described properties occur and loses due to the conductive indication, but materialized antenna that provide a high gain as well as what bandwidth still requirement. In order, research to design provides circular polarization with high gain directivity. The proposed work was applied to design a high gain antenna for wireless power transfer, WPT application, by using EBG layer with active element components due to enable dynamic transmittance with control circularly free wires over a specific frequency range. Direct antenna beam to certain point in the bore side with minimum side lobes. Increase the antenna gain at the bore side, certain frequency band to create a gas-one beam characterization. In this project, a high gain antenna based on UCBBG layers with 4 WPT is proposed. Such objectives: design a microstrip antenna with a certain frequency band of analyzed resonance to avoid the interference with other communications bandwidth, for example, 2.55 gigahertz. Realize a flat antenna structure with low profile of low cost and easy fabricate. Increase the antenna gain through using a certain UCBG layer with low profile. This is the design of the antenna which I make it. And this is of schedules and the frequency and frequency with the dB with sent signals. Conclusion. This study builds and show off portable wideband fractal antenna for 10 gigahertz WPT applications. The concept is based on the radiator lift to accomplish the wideband with frequency of operation 10 gigahertz, a circular range, and triangular fractal slots are built. This antenna grounds is kept probably to open with still of the middle to within the band even further. from 10.1 gigahertz to 12 gigahertz, and the antenna keeps its return loss at 10 dB while maintaining a 3 gigahertz bandwidth. When validated using HFF, the proposed antenna demonstrated good arrangement with the simulated data from CST. At 10 gigahertz, the antenna maintained gain about 7.1 dBi for 10 gigahertz WPT application. The suggested wideband antenna makes sense. Future works. The proposed antenna provides a single frequency bandwidth with enhanced gain. However, in the future, the authors would like to extend their works to operate over wide frequency with enhancement gain. The proposed antenna is designed from single layer to achieve a gain of dBi through extend wireless power transfer up to 3 kilometers with efficiency 90%. The antenna can be formed to transfer wireless power with further distance. The antenna can be designed from different UCBG layers to provide a future gain enhancement with enhanced bandwidth. Therefore, the use of fractal antenna and the UCBG layer could be very good suggestion for such works in the future. This is the reference of my paper, and thank you. Any question? Any question?
Thank you for presentation.
Thank you, Doctor.
Thanks for your contribution.
Thank you, Doctor. Thank you.
You're welcome. Your participation certificates have been uploaded to system. You can download on paper submission system. Is there any question? Okay. See you at tomorrow session. Good evening.
See you.